Welcome back to Chaoslands, and today we are going to replace the current world generator with a new world generator, because the current world generator looks a little bit blocky and that's really not nice. And I will show you what I mean in a second. So if we look at the map, we can see that there are the structure of blocks and the little blocks, and the little blocks are totally fine, but the huge blocks are not fine. So on the left side you can see that there's water and that it's basically a straight line going down, and on the right side you can see that there's like a rectangle of water, and I don't want that. So what I'm going to do is remove the old world generator code and create a new world generator and reuse parts of the current world generator or the old world generator. So it's time to start with that. The first thing on the list is to remove the old code, or I will just comment it out so we can look at it later. And at the bottom it's some code, but I think the code we will create will be much less. And as you would expect, when we start the game now, we get a world that's just filled with water, because water is the basic type, and if you don't apply some changes to the world, it's just filled with water. Let's close this again, and now I will begin to code. At the beginning we use Perlin noise, and that's basically a two-dimensional matrix that holds for every x and y coordinate a height value, and dependent on this height value we will determine whether the tile is water or land or dirt. And for example, if we have this matrix, if we will have positive and negative values, and every value that's negative will be water and every value that's positive will be dirt, for example. And I will create a different threshold, but for example this illustrates how this matrix works. Or how we will use it, and we will call the function getPerlinNoise that defines the Perlin noise and compare all those values if they are greater or smaller than 0, and depending on that create or place a dirt tile or no dirt tile. So the function takes 4 parameters, and the first one is the world width in both axes, so in the x and the y axis, and this is in our case 10 times 25 because we have 10 chunks and every chunk has 25 tiles. The next two parameters are the frequency and the amplitude. I will set both to 16. This is some configuration for the Perlin noise, and the last parameter we don't have to worry about this doesn't matter. Now we will loop through every tile in the world. Since we need the world size in the for loop, let's create a variable for this and call it world size. So we can use this in the loop and also in the function call. And first loop through the y-axis, and after that copy this code and loop through the x-axis. Now we want to somehow access a tile in the world, so let's first create the matrix of the Perlin noise so that we can access it. Now we check the y and x position of the matrix if it is greater than minus 0.33. Let me just check. It is at the moment always between 0 and it's always between minus 1 and 0. So let's go with minus 0.33. And if this is the case, we want to replace the value, and for that in this engine there's a variable or a type called CT position, and it holds the chunk and tile position. So it's basically two-dimensional vectors, and there's a function that we can transform the x and y position into this CT position. So in easy words, the CT position identifies a chunk and also a tile inside of this chunk. So there's a flat position and the CT position. And now for this, we want to transform the CT position, the flat position, into the CT position. And for that we call the function flat to CT. So what we want to do is to get from the world the current chunk, and we input the current chunk position. So the CT position point x represents a position of a chunk, and from this chunk we can call the function getTile and input the CT position point y, which represents the tile position, and can set the type to a type we want, and we will place it to the type dirt because we want to have a landscape in our game. And let's try it. So we want to create a new world and check it out. And as you can see, it's not just only water, they are all also green spaces where land is, dirt, and I like it, and that looks also better than before because you can't see any rectangles. They are always nice round landscapes. So let's keep going. The next thing we want to do is to create some mountains, and we do that similar to the dirt placement. We will just replace the value with a higher value so that higher matrix positions will transform to rocks. And we change also the type from dirt to mountain. And let's try it. I don't see any mountains, and that's not what I like, so let's check where the error is. So when we want to generate a mountain, we check for a value that is greater than minus 0.66. But the problem is that the branch before also checks if the value is greater than minus 0.33, and every value that's greater than minus 0.66 is also greater than minus 0.33, so the branch never gets called, so we have to switch the branches. And the second mistake is that the values that get generated from the Perlin function are between 10 and minus 10, and we just say if the value is greater than 1, we want to set it to 1, but that leads to the fact that we have many values that are just 1 and few values that are smaller than 1. But if we just delete this clipping, you can see that we get a world where the mountains are correctly generated, and I'm happy with the results, so let's keep that. Follow this channel if you like the video, and comment something and like the video. Have a nice day.